And welcome back again to First Python Notebook. I'm Ben Welsh, still here, still broadcasting live from Manhattan, USA. In our next chapter, we're going to learn how to start accessing, analyzing, and even improving the data columns that we have in our data frame or table. In our last chapter, we used Panda's read CSV method to read in this database of 163 fatal helicopter accidents, which were tracked by the National Transportation Safety Board here in the US. We learned how to read it in with read CSV, take a peek at it with head and tail, and kind of learn more about the data table across the board using the info method. In this chapter, we're going to pull out one of those columns and get to work. The one we're, of course, I think you can guess, most interested in, having looked at our story, is that make and model column, where each row equals one accident with one-to-many fatalities, and is then classified according to what was the make and model of the helicopter. And really, the research question of our story from the start was, which helicopter has had the most accidents, both overall, and then adjusting that as a rate, which we'll get to later in the class. And that information is stored in the make and model column, which tells us that this accident was a Bell 407, this accident was a Robinson R22, a Robinson R44, et cetera, et cetera. And so that's the column we're really going to work with to try to analyze this data set. So I'm going to go down to the bottom and I'm going to cut out this tail method with the X key or the clippers because we don't need it. And I'm going to try to get my hands on that column. So we start with our data table, which we saved in the accident list variable or whatever you happen to name it. And so if I want to pull out one of these columns, what I have to do is I have to do what's called indexing. And indexing is a very painful piece of Python jargon for pulling something out of a list or an array of data, right? And it's signaled in Python language by two flat brackets. So when you follow a variable with two flat brackets, you're going to be trying to index it to pull out of the table some subset of the records or an individual one of the records based on what you pass into the index. And in this case, we want to pull out one data column. We almost want to slice it off the data frame to look more closely at it. And its name is LA Times underscore make underscore and underscore model, right? And so I'm going to copy that little chunk of text. And then here inside the two brackets, I'm going to paste it. And so what we're doing is we're saying, hey, data frame stored in this variable, I would like to index from you or retrieve from inside your database this column, which I've put inside of quotes because it's a string, right? And now if I hit play following that, we'll see that it spits out an array of data that is just really that one single column that we saw looking at with head. We see the first 5 records, we see the last 5 records, and we see a little dot, dot, dot in the middle. This is just the Pandas default. They don't want to print everything just to avoid making everything very long. And what you see printed here before you is actually a Pandas series, just like the Pandas series that we created early on in this class with the even and odd numbers, right? It's sort of a super powered Pandas version of a Python list that you're able to analyze. Now, this list is full of characters and words, not numbers, not evens and odds, but labels or names for the different helicopters. And so this isn't the sort of data that you would do a sum on or a median or an average because it's a different type of data. But that doesn't mean Pandas can't analyze it. Pandas has its own separate set of shortcut functions to make it easier to analyze character data. And so if we go back to our cell, and if right after the index we type dot, we can access one of the most useful methods for analyzing a column of labels or words, and that is dot value underscore counts, open parenthesis, close parenthesis. And value counts, if you run it, you will see prints out a sort of grouped and counted analysis of how frequent each entry in that column is, right? And we see here that across all of the fatal accidents, 163 of them, the most common cleaned up model name from our LA Times column is the Robinson R44 38, right? So if our question is, which make and model had the most accidents or most fatal accidents, this single line of Python code is the answer to that question, right? And this is our sort of first demonstration of how I like to think about my interaction with a database journalistically, is I'm coming up with the question the same way I would as if I was interviewing a person over the telephone or on television, and then I'm asking the source to provide me the answer to that question. And here, my question is, which make and model has the most fatal accidents? And rather than, a person giving me the answer back, the computer is going to give it back. But to get the answer I want, I have to translate my question into Python so that the computer knows how to answer. And so there's a way in which that, to me, is kind of the proper to and fro of a journalist in the data set, is you're coming up with your questions, and then you're writing the Python that's going to try to get you those answers, right? Now, but anytime you ask a person a question, you listen very carefully to the answer. And you ask yourself, does that make sense? Is there anything missing from the response? Is there anything inconsistent? Is there anything that's a red flag, or does it make sense? And it's the same thing with the data source. As anyone here who's worked with data knows, data can be unreliable, it can omit things, it can have all kinds of noise and problems. And you have to be very, very careful and very fastidious about looking at the results or looking at its answers. And this is even in the case here when you have a column that I allegedly had cleaned up. And we see that problem if we look really carefully at this list. We don't just read the top entry and get all excited and say print it. We slowly kind of review the answer, and we do see a problem here. So our number 3 entry, Bell 306, is 28 accidents. But look, down here, Bell 206 appears in the data set a second time. And so there's the reality is we're not fully counting the Bell 206 accidents because we have 28 here in the 3rd place position. And then we've got 2 more down here further down the table. And those 2 records were not grouped together for a common total simply because they had different casings. This one was all caps and this one is lowercase. And that's an example of sort of a quirk or an oddity of how computer programs work. The computer thinks they're 2 different things, even though we know they're the same thing looking at them. And that's because the computer treats uppercase letters and lowercase letters as different things, at least in this context. And so this is a sort of obviously pre-engineered by me bugaboo that we put in here just to highlight the point that you have to be very careful and you have to look for what might be wrong or smell a little off with your data. And so the true count we can see looking at this is that 28 plus 2 is 30. And so while the Bell 206 might not climb to the top of our ranking, they actually will nudge slightly ahead of the Airbus 350. And so any ranking would properly say that Bell had the 2nd most accidents, not the 3rd, right? And how do you solve this problem? Well, this is where you have to get into something we talked about earlier, which is cleaning up your data, right? And so one of the major features and tasks of any data analysis, or almost all data analysis, is identifying small problems with the data and then coming up with ways to resolve them. It might be making your own columns like I did to group together common helicopter makes and models. And it's something more cosmetic and small like this. It might just be making all of the text in a column uppercase across the board just to avoid issues like this coming up. And so in this case, that is kind of obviously the solution. And so this is an opportunity now to learn another special pandas trick from the tool belt that applies to character columns. So for instance, if I'm going to copy and paste this access to our column, done with the indexing method. And then I'm going to, there is on any character column or series on a data frame, there is an str method, which is short for string, which is sort of a pandas alias to access for every record in the column, the underlying Python string functions that are built into the computer programming system that allow you to manipulate and edit text. And one of those things just happens to be upper. And so if you do the name of a character column, .str.upper, open parenthesis, close parenthesis, and you hit play, you'll see that it prints out pretty much the same thing, but everything is going to be uppercase. If I substitute in lower, you'll see that everything comes out lowercase, right? And so that is returning a column of data that is virtually the same as what we started with. It's just everything has been converted to either all uppercase or all lowercase. And so what we want to do is we want to take that uppercase column and we want to overwrite or save over the existing column in the data frame. And you can do that, and this gets a little verbose, but you can do that with the same equals operator that we defined variables with very early on learning Python. And so by taking our data frame and indexing the column to pull out that series, following it with the equal sign, whatever follows that equal sign is going to be overwritten or saved over the column in its original state. And so this is a little bit dangerous because you're sort of, destroying or overwriting what was there before. But in this case, we're being careful, and it's a very simple operation. So we're going to take this column and we're going to overwrite it with that same column, except with everything changed into all uppercase. And so if I put that line together and hit play, nothing happens, which is good news. Now, if I scroll up to my previous value count cell and I hit play again, it reruns the operation, but the underlying column of data has changed. And we can see now that Bell 206 has jumped up to having 30 total accidents, and that all lowercase record that we saw earlier is gone, right? Because the underlying data changed, our aggregation and our analysis changed too. Now, in the real world, data cleaning isn't often this easy and can require quite a bit more of messing around. It can require writing custom functions that classify or clean data. It can involve writing what are called regular expressions to identify patterns or problems in the text and cleaning it up. But in many cases, something as simple as this, trimming the white spaces off the edge of text, making all things uppercase, are just simple, hygienic ways to avoid having minor problems in the data create major problems in your findings. So that's it for this chapter on accessing columns. We'll be back in the next one to look at how we can use indexing to do a different task. We're going to use indexing to filter our data set to a subset of records.